Hello, this is Matthew, and welcome to today's video in which we are going to run an experiment using a bunch of old real hardware. What we're going to try to do today is create a VMS cluster across all 4 hardware architectures that VMS, later OpenVMS, has ever run on. So we turn back to the historical entry in this experiment. My VAX station 4000 here will represent, obviously, the VAX entrant into this experiment. And normally I have a broken tape drive that goes in here, but I don't have the right SCSI cable for the CD drive and an external SCSI enclosure to plug in. So I've just temporarily, it doesn't have the right mounting bracket or anything. But I have this cartridge caddy loading CD drive that actually has a jumper on the back to set it to the correct block size to work on VAX. I still have a caddy. The plastic has gotten pretty brittle, so one of the little tabs is broken, but it holds together enough to work. So we're going to see if that CD drive still works, if we can install OpenVMS from CD on the VAX station. And moving a little bit forward in time, of course, the VAX was succeeded by the Alpha. So I have my Alpha server DS10 here. This is going to be running OpenVMS. I believe it's version 8.4. We'll be running 7.3 on the VAX. That's the last version that supported VAX. Farther forward in time, Itanium, more colloquially known as Itanic. This is a dual Itanium 2 HP Integrity RX 1600. So this will give us our Itanium member of our cluster, also running the same version of VMS as the Alpha server 8.4. And then last, the newest entrant is this little Intel NUC that will allow us to run OpenVMS. I believe it's at version 9.2 for x86-64. Officially, that targets virtualization platforms. So this is running Debian Linux, and we're going to run VMS for x86-64 in a KVM VM, so native hardware virtualization. And if we're lucky, once these are all installed, we'll just be able to create a VAX cluster or VMS cluster and see if it even lets us, see if all of the members join and are able to do just basic cluster activities between them. So should be exciting. I don't know if this will work. I think officially VMS clusters allow you to have 2 architectures in them, and they have to be essentially siblings in time. So a VMS cluster with VAX and Alpha was supported. A VMS cluster with Alpha and Itanium was supported, but I don't think you could skip in time generations of processors, and you couldn't have more than 2. Now, I think those are just kind of official support requirements. I don't think there are software limitations that actually enforce those requirements. So we'll see if in fact, across 3 major versions of the operating system and 4 different hardware architectures, we're able to build that cluster. Now, I haven't pulled any of these out for quite a while, so I don't know what state these are in. I think the VAX station I last pulled out when I did the video on net booting it from a SimH emulated VAX. So I don't think there's a local operating system here. It would just have like the page file for the local page file, but it was set up to net boot from a different system as a satellite member of a cluster. So we'll install OpenVMS, clean, fresh install on all of these, and then we'll see if we can join them together into a cluster. So this video isn't really going to be about installing OpenVMS, but it's not something that we look at very often, so I will just kind of quickly walk through it on at least a couple of these. It starts looking very similar for the non-VAX install. But we'll go through that, see how far we get, and I'll probably just get DECnet and TCP/IP configured on each install. That's really all we need. We don't need extra programs or doing anything crazy like that. And then we'll try and form the cluster. So stick around and we'll see what happens. All right, welcome to the computer. Enough of that real world footage. The way I have this set up here is I have 4 virtual desktops, and we will keep our console and any other windows we end up opening for a given architecture on the virtual desktop for that architecture. So the first one will be VAX, and we'll be using this nice amber terminal. Second one will be alpha with our green terminal. Itanium gets this, what would you say, kind of cyan color in its terminal. And then x86, being the most boring and bog standard architecture here, gets good old boring gray. So we'll go through and install VMS one at a time here. Like I said in the intro, these systems are in who knows what various states. So for the VAX and Alpha, I have a serial cable connected to my desktop machine here. So their consoles are accessible over the serial port. Clear out my junk there. The Itanium, when we get to that, the Itanium has a remote management interface in it. So we will be able to connect to the Itanium's local console remotely over the network, which is good because I'm probably going to remove it out of my room here off my desk because it is very loud, even just being plugged in before you turn it on. And then x86, of course, I mentioned is running Debian Linux, so we will just SSH into that guy and manage the KVM VM and its console from there. So without further ado, step one, we need to install OpenVMS on VAX. So I'm going to use just Screen as my serial terminal program. And the first one, I should have these plugged in the right order. TTY USB 1 at 9600 baud. So with that open, I'm going to flip the power switch here on the VAX. And this was meant to be a desktop workstation, so it just has a little power supply fan in it. So it's reasonably quiet. You probably don't even hear the fan noise in the background on this microphone. So it'll sit here for a couple of minutes and then it will print, not even a couple of minutes. So it'll print this startup message. This thing has 40 megabytes of RAM. Can you believe that? What would you ever do with 40 whole megabytes of RAM? But it's telling you it has the KA46 processor. That, of course, is a large-scale integration VAX implementation on a chip. And it's going to go through here, run some startup tests. So we'll fast forward for it to finish those. Okay, there we go. So we'll see if I'm able to get it in the video here, but I hope you heard the little startup beeping sound. Near the end of the test there, the VAX station has a little speaker on board, and so it played that little tone toward the end of its self-tests. It started trying to boot from the network interface. Again, that may be a leftover from when we were doing the video to net boot this thing from another VAX. But there's a little button on the front of the VAX station to halt and basically interrupt and take you back to the system ROM prompt here, whatever you'd call that. So if we show devices, there's the network adapter. Okay, here we go. Now I hear the SCSI hard disk in it spinning up. So it had not powered on and spun up the hard disk yet. So it's interrogating that. There we go. So DKA0, that's the hard disk, 2.1 gigabytes. It's an RZ28. And then the CD-ROM drive is at DKA 400. That's just SCSI ID 4. And sure enough, that CD drive and that little CD caddy, everything looks like it's still working. I put that in there. So this is my installation media that I burned to a CD-ROM. So all we need to do is boot from the CD-ROM, and that should bring us into the standalone backup sort of kernel version of VMS. Okay, I hear the CD seeking. So far, so good. Yeah, this looks like perfect. This is working. All right, so this will just take a minute to boot, and you can see the weird version number here, X7G7. This is, like I said, kind of the standalone backup. I think is probably what it is, but it's just the minimal standalone kernel that we'll be able to run the backup restoration command on. So, okay, asking for the time. It is the 2nd of April, 2025. Let's say I'm probably going to do all these systems just in UTC. So that means that that's actually a mistake. It's now the 3rd of April, 2025 UTC, and it is 02:35. Okay, anyway, as I was saying, so this is the standalone backup boot media kernel. So the way you install OpenVMS on VAX is you restore a save set from the installation media to the hard drive. And that save set restores enough of VMS to then run the installation procedure when you boot from the hard drive. So it's going through, trying to detect any devices plugged in here. There we go. Yeah, so standalone backup 7.2. All right. So all we need to do is run the backup program, and we will restore from DKA 400, the CD drive, and that's going to be VMS 073.b, which is a save set. And we will just write that directly to DKA 0, the internal hard drive. So this is effectively going to wipe out any file system that's already on DKA 0 with whatever is in this save set. We'll then be able to reboot from the hard drive, and the save set here will have restored a bootable environment that will just automatically run the rest of the installation procedure. There we go. So that completed. That took, 3611 to 3752. So under 2 minutes. Not too bad. As saying, if we want to perform another, we can say yes or just halt and do whatever you want to do next. So I'm going to hit the button on the front of the VAX station again to halt. That drops me back into the ROM, and now I can just do boot DKA 0, and we will boot from the hard drive. Again, you see a slightly different version here. I don't know what BI stands for, probably something about like boot installation, but now we're for OpenVMS 7.3. That would be my guess at decoding all of this. So sure enough, installation procedure knows that it is a VAX station 4060. Nothing surprising here on real hardware. Everything just works and identifies correctly. So once again, the date will go with 03 April 2025. It is now 0239 Zulu. And here we go. It's going to run through the interactive questions for the installation. So I'm just going to use a consistent naming scheme here for the system disks. This is going to be VAX sys. And the distribution media, that was in DKA 400. And it is ready to be mounted. So it's reading from that CD now. And it's giving us the overview of everything that we can install and how much space it's going to take. So we have a little over 4 million blocks, so plenty of space to install all the software we could want. So yes, we want the library files. Yes, we want optional files. Yes, we want the message help database. No, we don't need the management station files. That's the little Windows management utility. Of course, as most of you know by this point, I don't really allow Windows in my house. Occasionally there's a need for it, and I'll temporarily spin up a VM. But anyway, the management station files are kind of interesting to play with if you haven't before, but we don't need them for our purposes here. Deck Windows base support, sure. Then we can remotely use X11 from this thing. And yeah, we'll take the 100 DPI fonts. Okay, DeckNet. We never want DeckNet Plus. We always want DeckNet Phase 4. The new DeckNet, basically a downgrade from old DeckNet. So yeah, that's correct. Okay, so it looks like it'll just read all of these installation packages off of the CD, copy them to the hard drive. So I'll fast forward through this part and see you on the other side. Okay, so that's going to confirm that we are in fact using DeckNet Phase 4, and we have a support addendum on our service contract. Sure, why not? Okay, Deck Windows Motif, the new exciting GUI interface. Yeah, we'll use that as our default windowing system. And now it'll ask for our passwords. So let me set all of these. Okay, node name. I'm just going to call these VAX AXP probably I64 and x86, so it'll be easy to identify. The system ID, so this, because we are going to use DECnet as well, I'm going to use area 42 and then 1, 2, 3, 4. So this VAC station will be 42.1. The way you compute the system ID from the DECnet address is you multiply the area by 1024. So 42 by 1024 is 43,008. And then you add the node number. So that bumps us up to 43009. And that's just some information about things you can do after your system is up and running. Okay, I won't bother with installing any license keys now. I'll do that later. We'll use UTC. And that's it. It's going to run autogen and reboot. If memory serves on the first reboot, it will expand or create the paging file, and it might do another autogen. I don't know, it does some things, and then it will reboot again, and we will be in our freshly installed OpenVMS 7.3 for VAX system. Okay, so it issued the reboot, but once again, the system is trying to boot from the network. So let me hit that interrupt button. And actually, I wonder if I can, is there a show boot? If I say set boot DKA 0 now, yeah, that should change the default boot. So let's boot from the hard drive again, and it'll complete the reboot. Okay, we are up and running. So I didn't remember what time we started, but it's now 02:54 Zulu. So that didn't feel like it took very long. All things considered, installing from an old CD-ROM drive to a old, slow, SCSI disk on a roughly 55 megahertz machine, it's actually a pretty zippy machine when it's running era-appropriate software. So we can log in here. If I remember my password. Good. Okay. Get the terminal set up correctly. The first thing I'm going to do here is add my license keys. So I'll pause the video here and we'll pick back up once the license keys are installed. Okay, that's taken care of. So now I'll just go through and we'll just do some quick preliminary things that I do on any new OpenVMS system. We'll do this on all 4 of the architectures here. We need to create the network proxy database. We won't be depending on the proxy database because we should have authentication amongst the cluster trusted just based on the UIDs. But this avoids that warning message or the error message at startup about the proxy database not being found. Okay, so there we go. Created net proxy. Next, we'll initialize the queue manager. So start queue manager new version. And then we'll make the sys batch queue. So queue start batch sys $batch. Okay. Let's see. What else do we want to do here? Let's, we'll need, I should probably consolidate all this, but for now, let's edit. It'll be sys startup startup_vms.com. Just before I forget, we will update. Oh, right. This is over 9600 baud. So it's not going to be the fastest thing in the world to scroll. But we'll start the sys batch queue in here. We're getting close. There's printer queues. Here we go. Start queue sys batch. Okay. And let's see. The other thing we can do, so we're going to need to install TCP/IP on this, and that's going to require some changes to the system parameters. So let's edit sys system mod params.dat. And here's where we can add in additional items here for the sysgen. So we're going to go min stack pages 20, add 10,000 global pages, 100 global sections, dynamic, this I think 8 million. Yeah, 800,000. And then in page virtual, another 800,000. Minimum for SPT rec is 6,000. And then minimum channel count is 200. For my notes, these are probably the values recommended by Multinet. We'll just be using the compact TCP/IP, but these values should work for that as well. So let's double check my spelling here. Global pages, global sections, number of pages dynamic, number of pages virtual, SPT rec channel count, which is fully spelled out for channel. Yep. Okay, so we'll save that. And we'll probably be ready just to go ahead and reboot right away with those new settings. Yeah, so let's do a sys update autogen get data reboot. Don't read the feedback data. Okay, so this will apply these updated calculations to the system parameters. Okay, that rebooted on its own successfully. So we'll log back in. And let's go ahead and actually it's my terminal up again. That should be fine. Okay, and let's set up DECnet, and then we'll install TCP/IP. Yep, that's correct. Okay, so the address, this time it'll compute it for us, so I'll just type in 42.1. We don't need to be a router. We don't need a default DECnet account. We'll just accept all the defaults here. Okay, it's going to give us a preview of the script it's going to run to set up DECnet. And yes, we will execute that. All right, so it generates, I think these are randomly generated passwords for each machine. Okay, so getting a lot of audit log messages as we'd expect as it's creating new security objects. Okay, do we want to start DECnet? Yes. There we go, circuit up. So if I show net, okay, DECnet, we're node named Vax at address 42.1. Looks good. Now let's mount, let's see, the CD drive. So that was DKA 400. And yep, I see the light on the CD drive spinning. There we go. So if we switch directories into the root of that CD drive, which the root of the VAX ODS, this would still be ODS2 file systems, is 6 zeros. So now we can see what's on the CD drive. The only thing I want to install is TCP/IP, so it looks like that's here. So we'll set def into that directory. And then kit. Oh, my keyboard mapping for the serial console is a little bit messed up. There we go. Great, it's a PCSI package. So I think all we need to do is just product install and then basically just give it that file name. Yep. Okay, yes, we'd like to continue. Yes, I'll take the defaults. We don't need to review anything. There we go. That will install. Okay, through the magic of video editing, that install process should appear to have gone very quickly, even though in real life it didn't. So the next step is to configure TCP/IP, and it actually gives us the command right there. So I'm just going to copy and paste that. And core environment is where we set up things like the domain and IP addresses. So I'm just going to do all options. These are my home network. And it does recognize that ESA0 interface as SE0. So we will configure that interface. This is going to be vax.home.mattwilson.org. 192.168. I'll give it 42.90. That's the correct subnet mask. That's the correct broadcast address. And yes, that's all correct. So move on to routing. We don't want to use dynamic routing or GateD. GateD is ancient, I think probably unmaintained software here. It's kind of crazy though. OSPF, BGP4, you can do all sorts of dynamic routing on your little desktop machine here. So yes, we'll configure a default route. That's .1 in my subnet. I don't care about giving it a name. And bind name, you can just give it an IP address and it'll skip making a name entry. So I'll give it, that's 42.2. And we don't need a name. And then I have a backup one at 64.2. Again, we don't need a name. Just hit enter when you're done. Okay, that's it for the core options. So now we just need to enable whatever clients and servers we want. I usually just turn on FTP and Telnet. Those tend to be what I use most often to interact with my VMS installs over the network. So we'll enable the client. And then yes, while we're here, we'll let it enable the server. So yes, enable service. Actually, I think we just did that. And then Telnet will do the same thing. Telnet, by enabling the client, always enables the server. You can't toggle them independently for some reason. Let's just go into the server components and verify. Okay, it didn't enable the server. It just brought me to the menu to enable the FTP server. So we'll say enable. We already configured the client, so we don't need to do that. And again, yeah, Telnet server is already enabled because we enabled the client. I don't think we need anything else right now. No, that looks good. So I'll exit that. And that's it. We'll exit. I guess we could have done startup from there, but we are going to... let's see. We'll actually just need to run the same script that we would run. I think it's a startup, TCP/IP startup. What we can do, because we need to do it anyway, is let's edit the startup script again. So sys startup startup underscore vms.com. Edited this file so many times that over the years this is burned into my brain. And again, slow to scroll at 9600 baud. But really, you can't read faster than 9600 baud anyway, so that's all you need, right? But what we're going to do here is uncomment the line to start up DECnet and uncomment the line to start up TCP/IP. So yeah, so we can just do start network, that, start network DECnet, and then here we go. This is the correct one for the current version. So let me copy that while I'm here. So sys startup, yeah, TCP/IP startup. So hit Control Z to save. And we can, let's see if that pastes. Yep. We'll start up TCP/IP. Now this VAX station doesn't have an RJ45 connector on the back of it. It has an AUI interface for the Ethernet. That's an attachment unit interface. So I have a little 10BASE-T transceiver plugged into that, and that then is plugged into a little network switch. So we will see if that still works. So I should be able to ping. Let's start simple and just ping the local gateway. Oh, is there a... yeah, there we go. It's under a TCP/IP program, inside of which I believe there's a ping command. It works! This old hardware, man, it just keeps on kicking. Okay, yeah, so this is a 10BASE-T. So that's 10 megabit Ethernet. We're not even talking fast Ethernet here, which was 100 megabit. This is 10 megabit Ethernet using an AUI 10BASE-T transceiver plugged into the AUI port on the back of this VAX station. And I can ping my modern, this actually, on the router side, this is a 10 gigabit Ethernet interface, and it works. So I should be able to go off of my network as well. Yep, so routing works. Okay, perfect. So this VAX station is on the internet. I'm trying to think if there's anything else we need to do at this point before we move on to the alpha. I may as well... let's create a directory. Does that create /dir? And this is going to be DKA0 users. And I'm going to add a local user for myself here. And then run the authorize program. So I'm going to add an MWilson user. I'll just give myself a temporary password here. Give it a nice name. So the dev here is DKA0. This is the device of the home directory, essentially. Normally, I'd set up a concealed translation, and you'd have like a fake device name like users that would go into this directory. But for the sake of, again, just keeping things simple here, I'll just do it this way. So dev is DKA0, and then the directory is going to be users.mwilson. And the UIC, I'm going to use 1500, 5000. So that's the group number in octal and the user number in octal. We do not want the user disabled. No password lifetime. And is it just priv equals all? That will let me essentially be the system user. Yep. Okay. And while I'm here, let's update the system user so that the password doesn't ever expire. So no password life on system user. I don't think I set no password life on my, let's do mod and Wilson, no password life as well. Perfect. Okay, I think we can exit out of that. We'll create the directory owned by, this keyboard mapping is going to drive me crazy, owned by MWilson, and that's going to be DK0 users MWilson. So now, let me start a new window here. We'll do another Amber xterm vax. Yeah, so now I should be able to telnet to 192.168.42.90. Yeah, sure enough, it works. So I can log in as MWilson with that temporary password. Let me change that before I forget. Change it to my normal one here. What? That's not too easy to guess. Whatever, I'll just leave it set to temp because clearly that's way more secure. Okay, so that's working. That is our VAX station. So we're on DECnet, we're on TCP/IP, and it's all set up so it should auto boot correctly, all of that. I'll just log off here for now. And we may as well immediately move on to the alpha. Okay, now we're over here in our green terminal. It's a similar setup, except this time the serial console for the alpha is plugged into, it should be TTY USB 1. Also, at a blazing fast 9600 baud. Okay, I'm going to reach over and hit the power button on the alpha server. There we go. Its fan has spun up. And let's see. We have a very fancy, futuristic tray loading CD drive in the alpha station. So all I need to do is push the button to open the tray, put the CD in, close the tray. All right. 512 megs of RAM. That is over 10 times as much RAM as the 40 megabyte VAX station has. Looks like we're just going to go through a couple of self-tests. It's the EW devices, 2 network interfaces. Okay, here we go. Oh, it has a built-in temperature sensor. So here it is, Alpha Server DS10, 617 megahertz. So again, spec bump from the 55 megahertz or so VAX station. Firmware dated 2007. So, on the newer side of what would now be considered probably somewhat vintage hardware. It's funny, they did carry over a lot of the same ROM interface from the VAX, the 3 chevron prompt. We can do things like show devices. So very similar. The shared heritage certainly shows here. All right, what do we have here? We have our hard drive at DKA0, and then we have the CD drive at DQA0. So without further ado, let's just go ahead and see if we can boot from that install CD. Okay, looking good. And there's our familiar prompt. So we are still the 3rd of April, 2025. It is now 03:55 Zulu. And as you can see, unlike on VAX, the alpha, and it'll be the same on Itanium and x86, install media actually runs the installer, the full installation process directly from the CD. So we don't have to do that initial restore of the backup save set and then boot from the hard drive and run the installer from there. So you saw the VAX install process. The alpha install process looks a little bit different, but it'll look essentially exactly the same on Itanium and x86. So since this looks a little different, we'll go through this one. We just want to do number 1, which is to upgrade, install, or reconfigure. We want to initialize our system. And let's just confirm what we have here. So what's it asking for? Target disk. Right, so target disk is DKA0. That's our hard drive. And it looks like we had an existing install that was labeled Alpha Sys. I'm going to follow my new convention for my new little set of 4 systems here. So it's going to be AXP Sys. We use ODS 5 with hard links. That's fine. And yes, that's all good. All right. Passwords. Okay. Trick question. It will eventually be a member of an OpenVMS cluster, but not yet. We're going to install the machines. There's no cluster for it to join. And I never even really knew what OpenVMS Galaxy was. Some cluster of clusters. I don't know. I should probably look it up. It's probably interesting. Okay, the node, this is going to be AXP. Yes, we plan on using DECnet. And instead of having to do the math, this will do it for us. So we just say 42.2 here. And we'll stick with UTC. Again, I'll enter the license keys later. Yep, we'll take deck windows. Again, we do not want DECnet Plus. We want DECnet Phase 4. And yes, we'll install TCP/IP. Convenient that it's now built in instead of having to install it separately like on VAX. We don't need detailed descriptions. And we'll take all the default options. Okay, so this error message is actually normal. I think this is just an error in the install media. You get it under emulators. You get it. I think it's just a known problem. So we do not want to terminate. We will just let it continue. And I guess we don't get the shipped help lib. I think help lib is generated. So, and again, DCL tables should be generated. So just don't terminate when you run into those errors, and then the installation will continue, and you'll end up with a working system. So nothing to worry about. Just, I don't know how they wouldn't catch this during testing when making a release, but my understanding is this is expected. Well, that took significantly longer than the much slower VAX station did. I think there's probably a universal rule of software at work here that the rate at which software bloat increases always outpaces the advances in hardware. Let's see, what's it telling us? It's telling us we can configure Kerberos. Yeah, we don't care about any of that. We'll just hit return. That seemed like a lot of information that it didn't give me the chance to read, so we'll ignore all that. Okay, you may shut down. We'll hit enter, and we will shut down this system. Okay, looks like we're back in the ROM. There we go. Let's show dev. Good, we still have a hard drive. Let's boot from DKA0. That's the same device name as a SCSI disk in the VAX. So yeah, again, definitely the shared heritage here of the Alpha platform being the direct descendant of VAX. Okay, here we go. So we're booted from the hard drive, OpenVMS Alpha operating system. We are at, where are we? 03, April 2025, 05, 30. Oh, it's 4:30. I looked at my wrong clock, but that's okay. We'll fix that. All right, so the system rebooted itself automatically to do the autogen. Let's make sure we can log in now for the first time. Excellent. Now, what's the... Is it... Yeah, same keyboard. Help set time? Yes, time equals time. Just give me an example. Okay, so we want... Oh, no, come on. There we go. So set time equals 03 April 2025, and then it's colon 0435. 5:52. That's better. That was an hour off before. Okay, so that's OpenVMS installed on the alpha. I will, again, pause the recording to track down my license certificates and enter those. And then I'm going to do the exact same things I did on the VAX. I'm going to create the network proxy database. I'm going to set up the queue manager, create the sys batch queue, configure TCP IP to give this thing an address, configure DECnet, and what else did I do? Create the users directory, create an mwilson user, create the mwilson users directory. And then this thing should be in the same state as the last install we did on the VAX. So again, it's all exactly the same at this point as it was on the VAX, except that we don't need to install TCP. I'll just run TCP IP config. So I'm not going to record that, and even sped up, it'll just be boring since you've already seen it. So I will be back here when all of that is complete. Okay, that is all done. The alpha system is up. It's configured. We are on the network. So if I show net here, our router is 42.2, and the IP address is 42.91. If I go into TCP IP, I should be able to ping the internet. That's all good. And I don't think I've tried this yet, but I don't have the DECnet name databases synchronized. We'll do that later before we set up the cluster, but I should be able to connect to the VAX over DECnet. So if I say set host and I give the VAX's DECnet address, perfect. Yeah, so now the set host is basically the DECnet equivalent of telnet. So I'm now at the VAX login prompt. So I should be able to log in as mwilson temp. Perfect. So yeah, so the VAX machine is still running over here. Let's log off of that. And now controls return to AXP. So these two machines are in the same state. Obviously a slightly different version of the OpenVMS operating system, but that'll be part of the fun of seeing if this cluster even works at all. So now we're ready to move on to the Itanium. Now the Itanium, unlike the VAX and Alpha, I don't have plugged in over a serial port on my desktop machine that I'm recording on here because I have the remote management card in it. So we should be able to telnet to that, and checking my notes here, that is at 192.168.42.180. Yep, perfect. Log into that. Yes, so the Hewlett-Packard integrated lights out for HP Integrity. So this is that HP Integrity RX 1600 server. It is a dual Itanium 2, each running at 1 gigahertz. So for this one, we can get remote access to the virtual serial console. And we can even look, it's kind of funny, the virtual front panel. We can see what lights on the front panel are on. We can see the system is off. So I can just hit Control B here to quit that. But what I want to do is power it on. So I don't have a CD drive, or it would be a DVD drive in this server. But I've copied the VMS for Itanium installation media to a USB key that's plugged into it. And because this has EFI firmware, we should just be able to use the EFI shell to browse around that USB key and launch the VMS loader. So we'll see if that works. But from the command menu here, the command we want is power control PC, and we want to power on. And it's confirming the system will power on. Yep. And then you hit Control B to get back to the main menu, and now I can pull up the console. And now we'll just wait for this system to power up and start writing information out to the console. There we go. ROM date 2007. What was the alpha server? Wasn't the firmware on that like 2006 or 2007? So some overlap, certainly, in terms of the supported lifetimes of these machines. Okay, there we are. Intel Itanium processor family. So EFI, the extensible firmware interface, was actually developed as part of Itanium. So as part of the whole Itanium platform. And then, despite the fact that Itanium was, of course, an absolute failure, EFI, Intel, and HP, and whoever else was involved with it decided that they wanted to use EFI on a bunch of other platforms and architectures, including x86, instead of on x86 the old, the old style BIOS system for booting and how all that worked. So EFI was on Itanium, and it was invented and developed for Itanium, and then they turned it into UEFI, the Universal Extensible Firmware Interface. The universal meaning for platforms other than Itanium. So that's pretty much really the only vestige of the Itanium project, I think, that actually stuck around and is now, all x86 PCs. And then you even see it in a lot of, I think, probably ARM and RISC to some degree. Some systems might be using it. But that UEFI, we can thank Itanium for that. All right, there is no bootable DVD. We can't boot over the network. But this luckily gives us easy access to the EFI shell. So we'll pull up the EFI shell. Great, we see our hard drive. And what I'm looking for here, yeah, the first one. Okay, so FS0 is the USB key. So it recognizes a file system that EFI is able to see. Usually that's a classic FAT file system. So if we just go to FS0, let's see what we have. Okay, EFI, VMS. And that's what we want, I bet. We should just be able to run VMSloader.efi, and it will just use this USB key instead of if this were on a CD that we were booting from. Okay, I assume the dots are a good sign. I actually have two of these Itanium servers. One of them does have a DVD drive in it, so that's the only one I've installed VMS on before. I've played around with this one actually booting from fiber channel storage. That's probably a whole other video, but I'd have to recreate that whole lab. So anyway, I think this is the first time I've tried to do this from the USB key instead of the DVD, but it should just work. We'll see how it goes here. Here we go. It looks like despite the fact that I set this X term to the cyan color, that menu there that had some colors, it looks like it ended up just resetting the text to this gray text. So we'll see at what point we can get our planned color back. At least you can still see the cursor as cyan, so you can still distinguish it from our green alpha and amber VAX. But we were planning on using gray for the x86 system. Those fancy terminal color codes messing up my brilliant plan. It's actually kind of funny as we go through the systems. That VAX had a 10 megabit 10 base T interface. The network interfaces on the alpha are fast Ethernet, so they're 100 megabit interfaces. And now on the Itanium, you can see we have moved up to the world that had the gigabit, the 1000 megabit interfaces. So yeah, we're marching forward through progress there for faster and faster Ethernet interfaces. All right, as you can see, this looks exactly like the alpha installation. Same menu. It's VMS 8.4. Is that the exact same version? Let's see what's. Yeah, so on alpha we have 8.4 2L1. Looks like on Itanium we'll have 8.4 2L3. So just a slightly updated set of, I guess, patches and everything from the factory. But yeah, we'll install it. And again, just because this is going to look exactly the same as the alpha, I will go ahead and just cut the video here, and we'll fast forward to the point where I have done the install and then all of that initial setup on the Itanium. So I will see you again in More than a minute for me, but just a few seconds for you. Okay, so the installation just finished, and I figured since this is one little piece that is slightly different than the alpha install, I'll go ahead and hit any key here. It's going to reboot after we exited the installer. And because this is an EFI system, that boot menu we saw when the server first starts up should have an entry that the installer added to the EFI boot entries list. And so instead of having to say, boot from DKA 0, which again, in VMS, they're using the same naming convention for SCSI disks. So local SCSI disk is DK. So the disk in this is DKA 0, just like on the VAX and the alpha. But what we should see is there should actually be a boot menu entry. Yeah, here it is. So in the EFI boot manager, there's now this first boot entry for OpenVMS on DKA 0. So it gives us time to change the selection if we want, but now it will go ahead and boot. So this is the first boot after the installation. And again, I'll just finish this all up with setting up TCP/IP, DECnet, the user, and we'll be back in a minute. And the excitement never stops here. I finished up the VMS on Itanium installation. So once again, we have DECnet, we have TCP/IP. I should be able to go, we can see set host. We'll do the VAX again, 42.1. Yep, so there's my VAX. And we can set host to 42.2 for the alpha. Okay. So far, so good. So now the only machine left, the fourth machine, will be our x86 machine. As promised, I did restore our nice cyan terminal for Itanium. If we go over to x86, that is the little Intel NUC running Debian. So that's at 192.168.42.29 at the moment. Oh, wrong username. Okay, and yeah, I prepared here. We have the installation CD. I have a new blank hard disk image. And if we look at the launch script, you can see here we're using QEMU in KVM mode. So this is the native Linux kernel hypervisor. And everything's set up correctly in one of the supported configurations for VMS for x86-64. We'll have it allocate a new pseudo terminal for the serial console. We'll have that CD available. We'll have the hard drive available. Bridge the network to my... I've set up this network bridge before, so it'll be on my network. And we don't want any VGA controller. We don't want any graphics. Starting in, I think, this most recent release, VMS for x86 added support for what I think they call the guest console. And that is how you can use the monitor and keyboard plugged into the server to interact with the VMS system console. Up until now, you've always had to do that over a virtual serial connection. So if you saw my video back from when VMS for x86 first came out, we had to go through the whole rigmarole of getting a virtual serial console in VMware. It's a lot easier in QEMU. It'll just allocate one we can connect to. But you don't have to do that now if you have a graphics interface and a monitor and keyboard plugged into the machine. So it is a little easier if you have console access. But I still want to do it over serial, just so we can do it all in the console here. So I'm forcing the machine to have no VGA controller at all. Even though you're supposed to have to turn on the guest console support, even if you turn it off, it seems like the installer at various points kind of forces it on. And then if you don't have your graphical console open, you're just stuck, even though you have your serial console connected. So if you are using a newer version of OpenVMS for x86-64 under QEMU and you want just purely to use the serial console, you just want this VGA none so that VMS doesn't detect any graphics hardware. and then no graphic. Basically, the combination of these two means no hardware, and then also QEMU won't launch its own GUI program. I'm not doing X forwarding or anything over this SSH connection, so I just want everything purely here in the console. So I should be able to launch that. And this is the QEMU monitor, and it says that it's created my serial device for me. So I'll actually launch a new window here. Let's do another xterm x86, so it's the right color. And I'll connect to that machine again, 192.168.42.29. And now, as if this were an actual serial port, I can do the same thing with screen. So I can just go screen to that, air quotes, serial interface. Yep, and there we go. So this is the serial console for the VMS x86 system. So I think it's not show dev here, you just say dev, and we can see right now the only bootable device is the CD. So we will boot DKA 200, and this will load up the OpenVMS installer. Okay, and as you can see, even though we're in the 9.x series now instead of 8.x, the installation process is essentially identical to what we saw in alpha, and then the way it works in Itanium as well. Right up to SCSI hard disks, DKA 0. And yep, that's actually the new naming scheme I've been using. So we will let OpenVMS install here. And again, I will be back after the system is installed. And then I'll probably skip again until the system is all configured. All right, that went pretty quickly. Certainly faster than the other three platforms. So return to continue. We shut down from the installer. And we get this, the VSI dump kernel, which handles shutdown and reboot as expected, and also crash dumps. Now, in my experience under KVM, this phase of shutting down, rebooting, whatever you happen to be doing, either takes a very long time to complete or never completes, no matter how long you wait. I don't remember this happening as often under VMware ESXi. It just seems to be some bug or problem, perhaps, in VMS running under QEMU KVM. So what I typically do at this point when I get tired of waiting to see if anything happens, and because I want to change the config to get rid of the CD anyway, is I'll just quit QEMU at this point. That'll shut down that machine. It disconnected my serial console. Let's update launch, and I'll just move this down to a comment down here in case I want to install again in the future. And then we'll just power the machine on again and reconnect our serial console. And here we go. So now we're booting off of DKA 0, the hard drive, and we can boot DKA 0. So this will be the first boot of the installed OpenVMS system. And you can see it's going through all the normal first-time autogen. It will reboot again. We'll see if it hangs at that VSI dump kernel. Can I turn off flash and xterm? How do I do that? Anyone see Visual Bell? It's already turned off. Oh, I wonder if it's a screen thing that's doing it. Yeah, anyway. Okay, so it's rebooting. Okay, it didn't hang at the dump kernel that time, so we'll just boot DKA 0 again. And this will let me log in for the first time. So again, I'll do all the same configuration I did on the other systems. And then we'll finally be done with just installing OpenVMS on all four of these architectures. And we will give clustering a try. So I'll be right back. And just like that, we have our OpenVMS on the node named x86. So again, DECnet setup, TCP/IP setup. We can go through the usual rigmarole, I guess. I can set host to, what do you want, the alpha, 42.2. Yep, so that's working. And we are, okay, back to node x86 here. So the first thing I want to do, now that I have all of these systems set up, is just make sure that DECnet names resolve to each other. And the way I'm going to do that, and there might be a more efficient way to do this kind of en masse, but let me log into the VAX. Now, if I run, I think I want to run the ncp command, set def sys system. There we go. So if I show known nodes, right, so the executor, this is the node I'm executing the command on, so 42.1, it knows that it is VAX. So I think I can do something like copy known nodes from, and then I'll copy from the alpha to both. So this copies to both the volatile and the permanent database on this host, on the VAX host. So now if I show known nodes, there we go. I know about 42.2 named AXP. So we can copy known nodes from 42.3 to both, and copy known nodes from 42.4 to both. So now if I show known nodes, we have our self, VAX, and then I know AXP, I64, and x86. So if I exit this, instead of having to say set host 42.3, I should be able to say set host I64. Yes, and now it knows it by name. I'm connected to the Itanium server over DECnet. So we can log in, we can log off, and that's good. Now I think I have to do this on each of the 4 machines to grab the name from the other 3 machines. Actually, I wonder, now that all of the nodes are known here, if I go to the alpha, let's set def sys system, run ncp. I think ncp stands for Network Control Program. It's what controls all things DECnet Phase 4. So again, if I show known nodes, there's nothing in here yet, but if I copy known nodes from 42.1, the VAX that now knows about all of the nodes, to both, and I show known nodes again, okay, yeah, that's perfect. It got all of the named node numbers, so I should just be able to go to each machine now and do the copy once, and everybody will know about everybody. So I'll do that over here on Itanium, log back in as system. And here we can copy the known nodes from, I'll just keep copying from the VAX, why not? Looks good. And last, we will do it over here on x86. Set def sys system, run ncp, and we'll copy the known nodes from 42.1 to both. Okay, great. And the reason that's important to do is if you end up using tools like Monitor Cluster, it communicates over DECnet to other nodes by their name. It doesn't necessarily automatically find them or talk to them over the cluster interconnect. So you'll want the names to work between the DECnet nodes of your cluster. So at this point, I think we're ready to just start trying to cluster these things. What I'll probably do is just make a 1-node cluster of the VAX. So it will have 1 vote and there will be 1 expected vote. So it should be able to boot on its own and form a cluster with just itself. And it'll just be sitting there waiting for any additional cluster communication over the network. And then I'll try to add the alpha to that cluster. And if that works, we'll try adding the Itanium to the cluster. And finally, if we're still having success there, we'll add the x86 machine to the cluster. So to set up the cluster, all we need to do is run, I think it's sysmanager and then cluster config. I'm going to do cluster config LAN, which I think ends up being the default on the other hosts, other architectures. I'm not sure if it was the default on VAX yet, but we'll be using the LAN for MOP downline loading. This is for booting satellites. We're not going to do that, so I'm not sure it's relevant one way or the other here, but we'll just be consistent. So we're going to add VAX. Again, this is the machine's actual host name. That's why we're seeing the word VAX there, to an existing cluster, or form a new cluster. So yeah, let's form a new cluster. Okay, will LAN be used for cluster communications? Yes, we don't have any other kind of interconnect. It's worth noting here that this will not be a shared system disk cluster. For one, I don't have any storage technology that can be shared between all four of these architectures. If we were just doing alpha, Itanium, and x86, you could conceivably do fiber channel. But I don't think there are even any fiber channel cards available for this VAX station. So there won't be any shared storage. And some of the cool stuff you can do with VMS clusters involved shared storage. It would be easy then to put the security database, the master queue manager database, all of those things on the shared storage, so all of the cluster nodes could use the same user database, for example. We're not going to be doing that. Our goal here is just going to be even getting them to see each other as cluster members. But just wanted to throw that out there up front here is, of course, across these four architectures, I just don't have any shared storage. And then for a shared system disk cluster, a system disk in a cluster can only support one architecture. So even with these, even if we did have a shared storage technology, we wouldn't be able to have shared system disk across the four architectures. We'd still need 4 different system disks in the cluster for the 4 different architectures. Okay, cluster's group number. How high can I go? Is 42 a valid group number? Yeah, looks like it. Okay, we'll give it a cluster password. And we don't need this to be a boot server. We will make it a disk server. What I'm hoping, and I don't know if this will work because I've never tried even a 2 architecture cluster, but even within a cluster, I'm used to having like a shadow volume, and so I don't really try and mount disks one to the other. What I'm hoping we'll be able to do, as one of the things we can do to show the cluster is working, is actually mount a disk over the cluster interconnect, meaning the LAN in this case, from another machine, not using DECnet, but using the disk server protocol. Well, VAX serves RFXX disks. I don't think that's the kind of disk I have. Okay, and I'm going to give each one a different allocation class, just matching their DECnet host number. So 1 for VAX, 2 for the alpha, so on and so forth. And again, with shared storage, the allocation class is important in terms of identifying unique paths or which paths hosts have access to the storage over. We're not going to use a quorum disk. And VAX will be a voting cluster member. Expected votes should be adjusted at convenient time before reboot, of course. I'm not going to run autogen now because we're just going to edit the parameters really quickly. So let's make sure my terminal is correct and edit. What is it? Sys mod params.dat. And you can see here, it added a comment. Let me scroll down. The cluster config utility is just setting up these parameters for the cluster. So it, in fact, ended up duplicating some parameters that are already set higher, like the node name and the number, but that's okay. And it's enabling the VMSCluster, send the allocation class. The one thing I want to do... Yeah, so votes is 1. I think I want to explicitly set... let me look this up really quick. I think it's just called expected votes. Yeah, so expected votes... in fact, here, I can do this. Let me open up a web browser for you really quickly here. So if I say VMS expected votes... Oh, all this AI crap that everyone is pushing on everyone. Here we go, VMS software. So expected votes specifies the maximum number of votes that can be present in a cluster. So it should be the sum of the votes of all the machines. And basically what will happen here is it will automatically then compute what constitutes a quorum. So if I have 4 votes, the cluster will need 3 votes to continue operation. Essentially, you would need a majority, and you can't have 50% exactly because then you'd be in a split brain situation. Each half of the cluster, if there was a partition where 2 machines were in one side of the partition and 2 machines were in the other, none of what am I trying to say here? Neither half would know definitively that it is the official continuation of the cluster. So if I say expected votes 1, then I will need this machine's 1 vote to bring up the cluster. If we get to the point where we have 3 machines in the cluster with expected votes equals 3, then if you lose 1 machine, the other 2 machines can continue operating the cluster. Any 2 machines can keep the cluster alive going forward if 1 drops out. Once I add the 4th machine, then we're back into the situation where, again, I can only lose 1 machine. If I lose 2 machines, 50% isn't enough. You need over 50% to be the continuation of the cluster in a partition scenario. So anyway, we'll adjust this as we go. As new machines come into the cluster, expected votes, I think, should increase automatically. But if we get to the point where all 4 are working in the cluster, we'll then go back and explicitly set expected votes to 4 on all of the machines so that after we shut down and reboot the cluster, everything is correct. Okay, so all we need to do now is apply those changes. We'll do the sys update autogen, and we will get data, which reads in that modparams.dat. We will automatically reboot, and we're not going to get feedback data. So with luck, this VAX station will still boot properly on its own, but it will consider itself to be in a cluster of 1 machine, with this machine being the only machine. If we're not lucky, the boot will just hang forever attempting to establish a cluster, and then I'll have to go look up, because I never remember how to do a sort of emergency interactive boot of the system to change system parameters at boot time so that we can turn this VMSCluster back off. So we'll see how this goes. Okay, moment of truth here. Waiting to form or join VMSCluster. Loading security database. Yeah, so MSCP disk server. This is that disk server protocol I was thinking of. That's not DECnet. This is its own thing. So what I'm hoping is that the cluster members will be able to access each other's disks over the MSCP protocol once they're in a cluster. Okay, so now we just wait. What we're hoping happens is this cluster should be formed. What it's doing, I think, is it sends out messages over the network saying, hey, is cluster 42 out there? Is anybody there? And it has to wait a certain amount of time to make sure that nobody is responding saying, oh yeah, cluster 42 is over here, come join us. if it doesn't get any of those responses, it should establish the cluster itself. And it just did, proposing formation of a VMSCluster, now a VMSCluster member, completing VMSCluster state transition. Okay, so that's the first hurdle. It can be very disconcerting when the system just hangs here forever, or it hangs trying to access its system disk or something else critical that just never comes back if it isn't happy with the cluster situation. Oh, I don't have a VMSCluster license installed. I will have to do that, it looks like. Okay, so the system is booted. So if I show cluster, yeah, so VAX is a cluster member. I think on a, even if you're not in a cluster, I think show cluster. Oh, okay. So it doesn't actually show member. It just shows yourself. So we are in fact in a cluster with ourself. Let me pause the recording here and I will see why that VMSCluster license wasn't loaded. So 1 second. Okay, I think I have the right license installed now. So just rebooting to make sure that it all works cleanly from a fresh boot. So it formed that VMSCluster again. We're still the only member. And this time I'm expecting to not see the message about a missing VMSCluster license as we go through the startup process here. All right, so while that's going, let's go over to the alpha. And we'll basically do the same thing. Let's run the sysmanager cluster config LAN procedure. And this time the host name is AXP. So let's add AXP to a cluster. Is the node to be a clustered node with a shared SCSI or fiber channel bus? Sadly, no, not at this point. Yes, the LAN will be used for cluster communication. And then you just need to put in the same group number and cluster password. That's basically the only thing protecting against someone, plugging an arbitrary OpenVMS machine into your same network segment and joining your cluster. Enable IP for cluster communication. Let's see. I think we want that. Sure. Ooh. In fact, actually, I don't think we want that. They didn't ask us that on VAX, did they? No, I might have messed up here. Okay, well, that's okay. We can, in fact, can I? Yeah, I'll just Control-C out of that procedure and run it again. Here we go. So no, yes, we're using LAN, but no, we're not using IP. We'll just use their, whatever the legacy network protocols are. Okay, so 42, password, no. Okay, yeah. Will not be a boot server. It will be a disk server. It's not serving RF disks. And this is going to be 2. No quorum disk. Expected votes value. Okay, so it's asking in this case. We won't have to edit the file ourselves. So now that we're going to have a second cluster member, the expected votes should be 2. Okay, so I'm going to say no here. Let's just go ahead and look at the systemmod_params.dat. Let's see what it said here. So yeah, so votes 1, expected votes 2. Okay, yeah, so it did everything that we want it to do. That all looks good. Network interconnect, not IP. It's not a boot node. Serve all disks. Yeah, that looks great. So we can run sys update autogen. And again, the usual parameters here. Get data, reboot, and no feedback this time. So theoretically, this second cluster member it's only one architecture generation difference, and it's only one major VMS version difference. So VAX with VMS 7 versus Alpha with VMS 8. So I think this would have been an officially supported cluster configuration. So hopefully we don't have a problem at this point. We'll let the alpha reboot here, and we'll see if it's able to join our cluster with our little VAX machine over here. Okay, our second moment of truth. Waiting to form or join a cluster. Okay, so sending VMSCluster member to request a system VAX. So it found the existing online cluster member for that cluster number. And we are now a VMSCluster member, system AXP. Well, so that's promising. So if we go over to, okay, so we're getting an info message. I is info. Different versions of VMS exist in cluster. I think that's okay. And yeah, now it's just running through the startup procedure. That's starting up TCP/IP. So if we go over to the VAX, so it looks like the opcom doesn't report cluster changes, but that's okay. Let's log in here. And if I show cluster, there we go. And of course, over here, if I log into the VAX, show cluster. Excellent. So they can see each other as being in the same cluster. So far, so good. Love to see it. So let me set term. Just show that again. Yeah, now the time's not getting cut off. Now, I think if I monitor cluster, because we have DECnet naming working, it should be able to grab data from both nodes, and we can have this kind of cluster-wide view. Yep, that's perfect. So we can see percent of memory in use for the cluster nodes. This will be lock activity. InQ, DQ are basically mutex lock and unlock. IO operations. So again, this is interesting. So on so allocation class 1 is my VAX, and that's DKA 0. It's just seeing a number for the disk name on allocation class 2, which is the alpha. But this should be cluster-wide disk activity. And I can do the same from here. Monitor cluster. Ah, that was an interesting message. Let's see if it shows. I don't know if you saw that, but it said there was some message there about some incompatible version. Yeah, okay, so the alpha version, the VMS 8 version of Monitor Cluster can't talk to whatever service on the VAX side serves up the data from it. So that's our first little incompatibility between versions here. That'll be an OpenVMS version incompatibility. If we were to install OpenVMS 7.3 for alpha on this alpha, I imagine we would be able to see it. It's interesting, though, that the VAX version can talk to the newer version of the software on the alpha. Okay, so let's get out of this. And I'm curious, if I show dev disks, or that start with D. Gotcha, yeah. So I can see now all of the disks across the cluster. And then again, allocation class in some ways can be thought of as the path to get to them. So $2 here is the alpha and $1 is the VAX. I have my local disk and my CD-ROM. And then over on the alpha, we have its local disk. And it's remotely mounted, but it's not mounted on this system. I don't think I can directly say yet $2 DKA 0 and show its root directory. Right, because it's not mounted. It's on AXP. But if I mount system, and I say that disk, and let's see, its label is AXP sys. It's mounted. Yeah, it's mounted locally. Okay, so if I do that again, if I say dir that device in its root directory, that's cool. So make no mistake, this is not going over DECnet. The syntax for talking to a node over DECnet is different. This is that MSCP disk server protocol that works between cluster members. So that's really cool. Now, let me go over to my alpha here. Now, if I show dev D, again, similar deal. I see the VAX disks, but they're not mounted here, and I see my local disk. If I log off and I log on as M. Wilson, I'm in my user directory on the alpha, right? This is the alpha's local disk. So let's just make a file here, and we'll just call it test.txt. So hello, I am creating this file on the alpha, saved to the alpha's local disk. Oops, I hit Control X, not Control Z. Apparently Control X is to kill the line. Hello again. This time I'll save the file. Control Z. Okay, it's here. So if I log off system, let me log on as M. Wilson on the VAX. And now again, the alpha's disk is mounted on this system. So I should be able to, and just again, so you can see all this, my local directory on the VAX is still empty. But because I have the same user ID on all of the machines in the cluster, the two right here, all the permissions should work correctly. So if I do dir, there's probably is it disk AXP sys users M. Wilson? Yeah, that's the automatically created symbolic name for volume labels. So sure enough, and so again, just to clarify, that's the exact same thing as using the device users M. Wilson. It should give me that same directory listing. So I'm able to see over the cluster disk server data on disks on other machines in the cluster. And because one of the important services of, the VMS operating system, but then also VMS clusters, is the distributed locking service, it's safe to have these disks mounted on the different cluster nodes because they will all coordinate locks appropriately to keep everything intact and keep all of the data integrity intact, all of that good stuff. You can write applications that use the cluster locking service, all of those kinds of things. Can I see queues in the cluster? Yeah, I think because I don't have a shared cluster-wide master queue database, again, that's something that would either need to be on one machine that's mounted on all of them, or again, preferably on shared storage, because if it's just on one machine and you're sharing it all from that one machine, you have a single point of failure in your cluster. So again, not as cool to do some of the clustering stuff without true shared storage, not just sort of this network storage to one machine. But nonetheless, this is good. So we can show that between these two machines so far, the cluster is working as expected, and we can do the cluster disk services. So now we are venturing into unsupported territory, where we are going to add a third architecture, and in fact, a third, no, not yet a third major VMS version, because the Alpha and the Itanium are both running 8.4. But you get the picture at this point, right? If I show cluster now, I64 is not yet in a cluster. Let's go ahead and correct that situation. What user am I? Yeah, I am system. So we'll do our old @sys manager cluster config LAN. We'll add to the cluster, no fiber channel, group number 42. No IP for cluster communication. We don't need to be a boot server. We will be a disk server. We will be, let's see, this was number 3. Yeah, number 3. No quorum disk. And expected votes is now going to be 3 because we're going to have 3 cluster members. And having looked at how it generates the parameters on the alpha, I trust it. So we'll just let it run the autogen and reboot. Okay, because of that HP boot menu, we lost our cyan color, but we'll just watch this here. So waiting to form or join an OpenVMSCluster. So far, so good. And then we'll expect it to see, okay, so it found AXP first. Now a cluster member. No complaints yet. So it's thinking about something. I'll just keep letting this play out in real time for a minute. We'll see what happens next. Let's see if we have any messages over here. So the alpha logged it received a cluster membership request. That's good. Vax hasn't said anything. Ah, there we go. Okay, so enable automatic disk serving. So it's starting up the disk server. And looks like startup is now proceeding normally. Okay, so it took a minute for some reason. Does seem like it's being slow. I'm not sure why. Okay, now it looks like the boot is proceeding normally. Yep, so it's all booted up. So let's log in. In fact, let me disconnect from the console here just so that we can get the correct color back. We don't want it to be confusing which machine is which. Yeah, so if I just relog in here. Okay, back to the console. All right, so if we show cluster, sure enough, not officially supported, but it is working. We have our Itanium running 8.4 with our VAX running 7.3 and our Alpha running 8.4. So again, if I go back to the VAX here, let's show cluster again. Yep, so the VAX is aware of what's happening. It's interesting that it shows a more abbreviated version of the software. Looks like they added more space in the display. It's probably just getting truncated. Or, yeah, maybe it's just a like legacy field versus a newer field they're showing. I'm not sure. But I'm curious, if I monitor cluster, wait for the first data refresh. Yeah, so the VAX is still able to get data. Oh, well, actually, that's probably a bug. We're not using 6,553,601% of the CPU on the Itanium. The memory number looks correct. Oh, it looks like it's a bug talking to the alpha version too. The way the CPU usage is scaled must be different on the newer versions of VMS. Okay, so a little bit buggy, but fundamentally it knows the machines are there. That's pretty cool. Now I expect if I monitor cluster here, well, yeah, incompatible version on VAX, but the Itanium should be able to show the alpha. Yeah, and it can, no problem. With no CPU usage calculation bug either. Cool, so that's looking good. Now, so far we have gone unsupported by having 3 architectures in a cluster with 2 major versions. Let's see if we can add the 4th architecture with a 4th major version, VMS v9. That, of course, is over here on our VMS x86. So, I think we're getting good at this. It is cluster config LAN. We'll add to the cluster, no fiber channel, cluster number 42. Interesting, it did not prompt to be a boot server. So booting satellite nodes from a VMS x86 cluster member may not be a supported feature on x86 yet. But we will be a disk server, so that's good. And let's go allocation class 4. No quorum disk. And at long last, we will be up to our 4 expected votes. And we'll let it run autogen. Now, once this works, we'll go back, we'll mount the disks cluster-wide again, and we can check, the disk interaction and everything between from x86 all the way back to VAX. This is interesting. It's actually extending the page file. I wonder if this collected some feedback data since I didn't manually run it with no feedback, and it decided that it would be ideal to increase the page file size. Well, we will give it approximately 120 seconds. Okay, pretty long, unexpected delay there to have the page file and the system dump file extended, but it looks like that finished. So now we are finally rebooting the x86 system. And again, instead of waiting for whatever this VSI dump kernel is doing, we're just going to restart QEMU. Okay, sending cluster request to i64. That's the one that it found first. Now a cluster member. So it hasn't complained yet about anything that it has seen that prevented it from becoming a member. And then, yeah, I'm guessing like Itanium, looks like it's going to hang here for a minute or two before it starts up the disk server. I'm curious at this point if I just show... Let's get out of this. Hello. Oh, you know what? The whole cluster is kind of hanging as it's trying to figure out what's going on here. Okay, there we go. So, yep, there it is, x86. We're actually getting opcom messages cluster-wide on the newer versions of OpenVMS. Or actually just alpha. It's kind of funny. Yeah, so if I show cluster here, well, there it is. I know I'm not the first person to do this, but this might be the first time on YouTube we have a VMS cluster on 100% real hardware with all 4 architectures that VMS has ever run on. So that's pretty cool. I don't know what kind of random crashes, bugs, problems you'd end up running into if you tried to do real heavy cluster activity with these 3 different major versions that we've already seen have some incompatibility, at least between even 7.3 and 8.4 between VAX and Alpha for that CPU counter and for the ability of the newer machines to look at lower version monitoring. But fundamentally, the basics here appear to be working. So, okay, let's just make sure. Yeah, so we finished up the x86 startup. Let's log in. If I show the cluster, that's good. Let's see what we get with monitor cluster on x86, because this is now going to be looking at one major version back for Alpha and Itanium, and then of course 2 back. So we expect to not be compatible with 7.3. We'll see if they maintain compatibility with 8.4. I just have to wait for the first refresh. Yeah, okay. So the OpenVMS 8.4 on x86 is able to get that monitor data from, or sorry, VMS 9.2 on x86 is able to get that monitor data from VMS 8.4 on the Alpha and the Itanium. So that works as expected. What else can we do here? Oh, right. So if I say show dev D, we have the VAX disk, we have the Alpha disk, we have the Itanium disk, and we have the x86 disk. And what I should be able to do now is if I say mount system cluster wide, I should be able to do a cluster wide mount of disks in one go. So that disk, which is labeled VAX cool. And now if I mount sys cluster the alpha system disk, AXP sys, perfect. Folks, this is working. And the Itanium disk, which is I64 sys. A little bit of hang time, but it worked in the end. And last but not least, so this disk is already mounted on this system, of course. But if I do the cluster-wide mount, interesting. Failed to mount on node VAX. Files 11 home block not found on volume. So there's an incompatibility here. So the VAX disk, so this is ODS 2. And then this disk is formatted with ODS 5, and this disk is formatted with ODS 5. And actually, x86 uses ODS 5 as well. So it's interesting that the Alpha ODS 5 disk and the Itanium ODS 5 disk successfully mount on the VAX, but the x86 ODS 5 disk could not mount on the VAX. One guess that I would have, without actually knowing what's going on, is that maybe the x86 disk is too big. This is a 64 gig disk. No, actually, because the Itanium disk, I think, is 70. Do I have a 16 gig disk or a 72 gig disk in there? Show dev full. We'll just show the Itanium disk here from the x86 box. Free blocks. Does that tell me anything useful? Oh, that's interesting. It knows it's an RX 1600 at 1 gigahertz. Okay. Oh, yeah. Total blocks. I always forget. Are these 512? Let's say, so what's my local disk? DKA 0 full. Whoa. Oh, it's showing all. Sorry, I need to be explicit here. This is going to be dollar x86 is 4, right? $4 DKA 0. This is total blocks. 134 million. Yeah, so this is actually smaller than the Itanium disk. So it's not a disk size thing. It must be something about the x86 or the VMS9 disk server. But in any case, so if I look here, show dev mounted. Yeah, so it successfully, of course, it has the local disk, successfully mounted the alpha disk, which we already demonstrated when it was just the 2-node cluster. It did successfully mount the Itanium disk, but for some reason, and just to confirm, mount system. Let's just make sure we can't mount it locally either. That's x86 sys. Oh, I'm not logged into sys. Set proc priv equals all. We'll try that again. Yeah, so something about the x86 disk server. Looks like the VAX is too old. Really, it's probably not even a VAX problem. OpenVMS 7.3 might be too old to mount disks from the OpenVMS 9 MSCP disk server. But it's kind of cool that it works for Alpha and Itanium. Now, from this side of the world, let's just confirm show mount. No, show dev mount. Yeah, here on the OpenVMS 9 on x86, it is still able to mount from the VAX version, VMS 7.3 disk server. So again, from x86, yeah, that's what we're on here. From x86, I can say dir disk vax sys users.mwilson. Where did I make the file? I made the file on AXP. So that's correct. No files in that directory. I can see it on the alpha. And of course, I should be able to actually look at the file. There it is. I can edit the file. In fact, we should be able to edit a file on the VAX. So if I go back to disk vax sys mwilson new file.txt, this is a file I'm creating from OpenVMS 9 on x86-64 over the cluster is it MSCP or MCSP? I forgot the abbreviation already. We'll call it MSCP. Over the cluster MSCP disk server protocol on an OpenVMS 7 VAX system. How cool is that? Okay, so that's there. So now from the Itanium, I should be able to type, what was it? Disk vax sys users mwilson. And then that's going to be new file.txt, but it helps if I spell disk correctly. Yep, so the Itanium is able to read that file. Now, again, for home directories, usually these would be on either shared storage or you might have a shadow volume between a couple of cluster members, so you at least get some redundancy, and then you'd have that shadow set mounted cluster-wide, under a common logical name. But again, you can see the pieces here are all working, despite the lack of any shared disks or mirrored volumes or anything like that. That's actually very cool that this is working. I'm very happy with this outcome. It would have been a shame to have installed all of those copies of VMS on the different systems just to have clustering totally not work. I think the cluster clock should be synchronized now. I'm not. How can I test that quickly? Let me. Let's start my VAX color here, and we'll just telnet in to, what was it, 192.168.42.90. Oops, that's not my password. It's going to reject me here. Okay, so if I then open another, actually we'll just do that here, and what's it doing? I never use XFCE. It looks like I'm dragging across. That's going too quickly. Help. Just go one desktop. Okay, we're back. So let me move this. I don't want it to jump. Okay, and then let me move this over here. So if I show time, how quickly can I... Okay, so it's a couple seconds off, but when I was manually setting the time, I don't think I was doing it that closely. So I think there is some kind of cluster time synchronization going here. The other thing we can do, make sure I'm still sys. What's my user? Yeah, I'm system. Okay, so I think I can do set time cluster. What's the syntax going to be here? It's going to be set time equals, we're at 03 April 2025, and it is 07, we'll call it, it's actually going to be 4705 Zulu. I think if I add the cluster tag to this, I'm going to enter right at 05. There we go. So now if I show time, okay, yeah, so that did set everything cluster-wide. If the local clocks run at different rates, I don't know if the cluster will just let them continue to drift or if there is some degree of attempting to do time synchronization among the cluster. So anyway, that was just one thing I wanted to look at there. Okay, so let's exit my telnet session. Yeah, so now we're back to the console session of the x86 box. Yeah, I don't know at this point if there's really anything else we should look at or try to do with our cluster, but oh, I know. Okay, one last thing, and then again, this video, like all of them, is going to be very long. But the last thing we want to do here is edit sys manager mod params.dat. Nope, that's not it. Is it sys system? Edit sys system. There we go. Yeah, so we need to set expected votes to 4. I also need to fix my keyboard layout here. So expected votes 4, and we're going to do this on all of the cluster members. So let's do that. Let me just copy and paste this command because it'll be the same on everything. Oh, never mind. Oh, where is it on alpha? What? Oh, it's because let's actually log in as system. Okay, let's try that again. So this one needs to be expected votes 4. And I'm system on this one. So on the Itanium, expected votes 4. And then x86 is already set to expected votes 4. So let's do the old sys update autogen, and we are going to say get data, reboot, no feedback. Let's see, let me think through this. So if a machine starts to reboot, if enough machines reboot to not have quorum, the cluster's going to hang. So let me... okay, I'm just going to do one at a time just to be safe, and then I'm going to want to do something different. But yeah, let's do one machine at a time here. Okay, so while that's rebooting, if I go over here, yeah, so there's some state transitions. So if I show the cluster at this point, where are we over here? It's already trying to reform the cluster, so this command may actually be blocked until the state transition finishes. But we would have, we would have briefly seen the cluster without the VAX node, but now the cluster is in a state transition, and we see the membership request from VAX. So, so in fact, okay, yeah, MSCP. It's sending the request to x86. Can x86 handle that request from the older version? Or did we get unlucky? Do we need to get lucky and hit AXP or i64? That would be interesting. Oh, okay. It looks like it worked. I'm not sure why it took 4 tries. Again, I don't know if that's some little incompatibility between VMS 9 and 7. If we had hit, AXP or i64 as the first machine we discovered, I wonder if that would have happened a little more quickly. Or it was just waiting for the x86 machine to coordinate with the other 2 online cluster members before it could fully let me in. So a little scare there, but that's good. It looks like it's working. So now that is a cluster member again, and where was that show cluster command hung? Oh, it was probably up farther, but if I show cluster here, yep, so that's back in the cluster. If I now do the alpha host, so again, redoing the autogen with the new parameters so that the expected votes is set to 4 on all of these machines. So the VAX is successfully rebooted. And now the alpha's going down. It's funny, I don't know why the opcom messages are showing on some cluster members, but not all cluster members. Okay, where are we on alpha? So when this one reboots, it actually reduces the active expected votes in the cluster. So that would prevent the cluster from hanging until the expected hosts come back. I don't think the VAX did that. If it did, it certainly didn't say it. Okay, so at this point, whoops, I think I mistyped that. Yep. So the cluster shouldn't be hung. Yep, okay, so that's as expected. We have the 3 members. AXP host is currently broken, non-responsive. I think that's probably what that means. But as soon as it reboots here, it will rejoin the cluster. It may disappear entirely in the meantime, but no, it'll probably be back before that status changes. Okay, yeah, so that happened very quickly. It requested membership from x86, and it became a cluster member. Oh, no, this is an interesting EWA 0 possible duplex mode mismatch. So this is a network thing. I wonder if that little 10-base-T transceiver on the VAX station, even though it's plugged into a switch, I wonder if it's causing some problems. Weird network interface stuff. But anyway, that shouldn't cause any real problems for now. So yeah, so AXP is rejoining the cluster. There we go, starting its disk serving, and now it's running the normal OpenVMS startup, so that's good. In fact, if I show cluster, it should already show as a successful member. Yep. So that means we're safe to now... Oh, I lost my copy buffer. What is it at? Sys update autogen get data reboot no feedback. Okay, so let's restart the Itanium. Make sure... Yep, alpha is starting up normally. Everything looking good still. Okay, yep, so the alpha started back up. Everybody happy over here? Yep, x86 is still happy. So what I want to do after this is the last machine we need to reboot because the x86 machine already has the 4 expected votes. But the last thing I want to do after this reboot happens is I want to shut down all of the machines in the cluster and then start them all up basically at the same time. But they should wait for at least 3 of the members to join the cluster before they proceed with booting. Because if all 4 machines are shut down, when you boot the first machine, it knows the expected votes are 4. So if it's on its own, it has no way of knowing if the reason it's on its own is because the other 3 machines are shut down. I'll hit enter here. In which case, yeah, it could be the cluster by itself, but it has no way of knowing that. The other possibility is that a network partition has happened. The other 3 machines are running, and they are happily providing forward progress for the cluster. But the one machine, in this case, the only machine that's even powered on, has no way of knowing that that the cluster is or isn't alive. So that's what this whole quorum thing is about and the expected votes. So when I start a second machine up, it should see the first machine, and they may be able to talk to each other, and they may realize that they're in the same cluster. But again, they have no way of knowing, as 2 machines that are only able to talk to each other and essentially contribute 2 votes to their cluster that they're in, if the reason there are only 2 votes is because the other 2 machines are powered off, or if there was a network partition and these first 2 machines are on one side of the partition and the other 2 machines, which could be the real cluster, are on the other side of the partition. So it's not until the third machine starts up, joins the cluster with the other 2, where they say, oh, okay, we now have a majority of the votes. We have 3 votes out of the expected 4. Therefore, we know that if that other machine is online, because it can't talk to us, it knows that there aren't 3 votes. So it knows it can't possibly be in the current true cluster, the portion of the cluster that is able to make forward progress as a cluster. And so those 3 machines would then fully form the cluster, boot up, be usable, even though that 4th machine isn't booted yet. And then when the 4th machine boots up, rejoins the cluster, then the cluster is complete. And of course, the 4th machine, along with the 3 machines that were already making forward progress, are able to operate normally. Now, I'm not going to play it out that slowly one at a time. I'm just going to shut them all down and then start them all up. And that process will basically play out with whatever the first 3 machines to boot and join the cluster are. They'll then continue booting normally. And then whatever lags behind is the 4th machine will just join that newly reformed cluster of the 3 machines that get there first. Okay, so that's the Itanium rebooted. And now again, let's just show cluster one more time. I love this display showing all 4 architectures with the 3 different versions. But we'll go ahead and sys shut down. Nope, sorry, that should be sys system shut down. Standalone, no, yes, no, later. Now, this is important to do. We need to do this remove node option because this will tell the remaining nodes that it's not a missing vote. It's actually going to reduce the expected votes to 3 on all of these. And that'll be important as we turn off each machine at a time, because we don't want, once we shut off the second machine, we don't want the 2 remaining machines to just be stuck. And they will literally just freeze. They won't do disk activity. They won't do anything because they don't know what the lock states are in the cluster, anything like that. So if you're intentionally shutting down a node, you just say remove node, and that will change the sort of dynamic. It won't change that permanent on disk parameter, but it'll change the dynamic expected votes in the cluster on the remaining cluster members. Okay, so we can do the same thing over here. It's going to be annoying typing with these messages going by. Let's do sys system shutdown 0. Ugh, those opcom messages are so annoying. Yes, 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 no, later, and then again, remove node. Okay, shutdown complete. And like I said, here's a little bit of a hang as the cluster figures out what's going on with this reconfiguration, because as I hit enter here, nothing's happening. Let's shut down the x86 machine. So sys system shutdown. Yeah, so while these cluster transitions are happening, we can definitely get some pauses as the OpenVMS kernel is sort of reconfiguring and figuring out what's going on. And here we go. Now forward progress has resumed. And yep, so this is responsive again. Okay. Remove. And actually there's this cluster shutdown command, which if you're shutting down all of the machines at the same time, assuming compatible versions, I didn't see that as an option on 7.3. It can coordinate things that way as well. So actually, I don't know if I'm gonna regret this. This is the Itanium. Sorry about the wrong color, but because of the reboot, we lost the color. I'm gonna say cluster shutdown just to see what happens here. And again, x86. We will probably also want to do cluster shutdown so we don't get ourselves in a bind here between these two nodes. Okay, so let's monitor things here. So the VAX is shut down. So I'm going to hit the console interrupt button there. And so now, yeah, we're just back at the boot prompt on the VAX. Alpha, that shut down. And now we're just waiting for the Itanium and x86 to shut down. There we go, x86 shut down. Again, it may just hang forever at VSI dump kernel, or it may not. And here's the Itanium shut down. Perfect. So let's just do our normal cheat and quit QEMU here. We'll relaunch that. Okay, so this is going to be the final test of the video, where it really all comes together as we've completely shut down the cluster. And now booting all these machines should reform the cluster. So I'll just say boot DKA0. I think I said the boot device. We could have just said boot. So I'll get the VAX going. We will boot the alpha from its DKA0. Itanium, I don't think I can... Yeah, despite the chevron prompt here, any key is just going to cold reboot the system. So I'll hit the any key. And then x86 here, we will tell it to boot. So what's happening around VAX? Okay, so the VAX is waiting to form or join a cluster. And the alpha is waiting to form or join a cluster, right? So this is a different message we were seeing where when it starts up and there's already a cluster on the network where it says sending cluster join request to VAX or to i64. So it's sending out those feelers. At this point, they're probably certainly aware of each other sending out these broadcast messages, but what they're waiting for is to see if anyone in an established cluster is there. So the timeout passed, and so it looks like the VAX was the first one to now propose the formation of a new cluster. And the alpha joined that cluster. And yeah, the Itanium also was able to form and join the cluster. So do we see a... Yeah, there's a cluster member. So we have quorum. So these things. Oh, and actually, it looks like x86 beat it. Oh yeah, x86, of course, is a much faster machine, so it's up and running as well. So that all worked. Basically, while it wasn't perfectly clear to see, what I described earlier is uh, everything kind of waited until 3 machines were online, and the 3 machines, it turned out, were VAX, the Alpha, and the x86, I think. I think the Itanium was slightly late to the party. And now that it was able to form that cluster, everything is proceeding. And as soon as we're able to log into the first machine that actually finishes booting, we will be able to confirm that everybody's there. So it's either going to be the VAX here or the Alpha, I think. Yep. Well, or x86. Is that booted yet? Yeah. So system. So if I show cluster at this point, opcom messages, we'll do it on the VAX. Sure enough, all 4 machines are back. Now, again, if I do, let's do this from the Itanium. Hold on, let's get our correct Itanium color back. I know that's very important at this stage in the video. We don't want to confuse the Itanium with the x86. Okay. So again, I don't have startup scripts that are doing the mounts, but we can say mount system cluster, and we can redo all of those mounts. So that's vax sys. And we'll do the same thing for $2 DKA0, which is AXP sys. And $3 DK0 is I64 sys. That's our local disk. And the x86 disk, which we are expecting to see an error about can't mount on VAX. That's fine. But now if we show the mounted devices, yep, cluster-wide, we have all of the disks mounted. If I go back to Alpha, we should see the same thing. I'll log in as a regular user. There we go. Wow, the Alpha and Itanium disks are very similar sizes. I'm guessing those are both 72 gig SCSI disks. So there you have it. I'll show the, actually, let me set term inc. Show cluster. Like I said, I'm sure I'm not the first person to do this, even on real hardware, but probably a YouTube first. 4 architecture, 3 major version, VMSCluster on 100% real hardware. We have a VAX, we have an Alpha, we have an Itanium, and we have x86 64. This whole exercise is probably entirely pointless. Again, lacking shared storage. We've already kind of met the limits of the sort of interesting things we can do in the VAX cluster. If I had a second disk in the Itanium and probably the x86, or if I had a second disk in the Alpha and the Itanium, it might be interesting to do a shadow set between them, so mirrored storage between them, and then maybe use that for some common files, like maybe the user home directories cluster-wide. So you could do that sort of thing without having an actual physical shared storage interconnect. But that's not particularly different than doing a shadow set, on a VAX with multiple disks, or even between a couple of VAXs that have some extra disks. So nothing really groundbreaking there in terms of cross architecture. Again, I don't know what the version compatibility would be. I don't know if you could do a shadow set between 7.3 and 8.4. Probably, again, given that I think the one version difference, one architecture difference was a supported configuration as people were transitioning from VAX to alpha. But that'd have to be something that you try perhaps on your own. But for now, I'm very happy with this result. Like I said, I had no idea if this was actually going to work. We did find a couple minor incompatibilities just with this basic poking around we've done. Again, if you actually start writing programs that are using the cluster APIs and trying to do stuff between the machines, maybe there are some additional incompatibilities. But cool to see this working. Hope you enjoyed the video, and if you have any real-world VMSCluster, VMSCluster experience, let me know what you were using that for down in the comments. Otherwise, this was a fun experiment. I'm glad I got to put all this hardware to use. Some of this stuff, I think I got the VAX station in about 2002, 2003 at the latest. So always fun to pull that out from time to time. Like I said, I did one other video on the channel with that actual real hardware VAX station, so I'm happy that it's still alive and kicking. But then being able to pull in the alpha and the Itanium and actually do something with all of this VMS capable hardware was pretty fun. So thank you so much for watching. And as usual, I don't know what the next video will be, but whatever it is, I hope to see you then. Thanks. Goodbye.